Something strange is happening at CERN nobody can imagine. Nobody can understand the bizarre events that are taking place at CERN. Even though science frequently seeks to help us understand the world around us better, the idea of a man-made machine exploring the very structure of the universe is an odd one to consider. Some people still think that crazy scientists are working on devices that could send us to an alternative reality, launch us toward the gate of hell, or even harness the force of a black hole. On July 5th, CERN started up its massive particle accelerator, sparking a lot of speculative discussion about the more unknowable effects of scientific research and the mysteries of the wide cosmos. Will the newest CERN project enable us to make groundbreaking new discoveries we will eventually perish as a result, or not? However, there is no denying that unusual activity at CERN is occurring, unimaginable as it may be. Organisationally, CERN is genuinely exceptional. A sincere partnership between nations, academic institutions and researchers that is motivated by a shared desire to learn and share information rather than by the pursuit of profit. Massive scientific breakthroughs made there by locals are pushing the boundaries of knowledge and providing solutions to some of life's most difficult problems. A genuine culture of trust is fostered by the fact that experts from every discipline congregate there to partake in this goal, and by the collaborative global community it fosters. Their history is being made, and this is resulting excitement is palpable, motivating and occasionally overwhelming. On July 5th, the Large Hadron Collider, the LHC, was powered up for the third time, allowing researchers to uncover 3 exotic particles, 10 years after they first used it to locate the elusive God particle, also known as the Higgs boson. Scientists have discovered a pentaquark and the first ever pair of tetraquarks at CERN, the European Laboratory for Particle Physics, which is located near Geneva. Following a 3-year hiatus, the LHC was restarted in April. On July 5th, it was powered up to previously unheard of energies, and started smashing protons together almost as quickly as light. This could reveal new physics that deviates from the standard model. Through the year 2026, the current testing phase will continue. We examine more closely at the run, what has been discovered thus far, and what this discovery means as the scientific community celebrates this discovery. Here's a quick overview of the LHC before we delve into the discoveries. The largest and most potent particle accelerator in the world is called the Large Hadron Collider, LHC. It became operational on September 10, 2008, and it continues to be the newest component of the CERN accelerator complex. The LHC is made up of a 27km ring of superconducting magnets and other accelerating elements that serve to increase the energy of the particles as they travel through the system. 2 high-energy particle beams are accelerated into the accelerator and made to collide while moving nearly at the speed of light. 2 tubes that are maintained at an ultra-high vacuum carry the beams in opposite direction motion. An intense magnetic field sustained by superconducting electromagnets directs them around the accelerator ring. The construction of the electromagnets uses coils of specialized electrical cable that function in a superconducting state, efficiently conducting electricity without loss of energy or resistance. To do this, it's necessary to cool the magnets to 271.3 degrees Celsius, which is colder than space. This is the reason that a large portion of the accelerator is linked to other supply services as well as a distribution system for liquid helium, which cools the magnets. The beams are guarded around the accelerator using tens of thousands of magnets in various shapes and sizes. There are 392 quadruple magnets that focus the beams and 392 dipole magnets that bend the beams. The length of each dipole magnet is 50 meters. A different sort of magnet is employed to squeeze the particles closer together just before the collision to boost the likelihood of collisions. Because the particles are so tiny, it would take a lot of precision to fire 2 needles at a distance of 10 kilometers, such that they meet halfway in order to cause them to collide. The CERN Control Center has a single building that houses all of the accelerator's controls, as well as its service and technological equipment. From here, the beams inside the LHC are made to collide at 4 sites around the accelerator ring, which correspond to the positions of 4 particle detectors: Atlas, CMS, ALICE and LHCb. The construction of the LHC reportedly took 10 years and cost $4.7 billion in total. Over 70% of the programme's annual budget is contributed by CERN member nations, with contributions from Germany, the United Kingdom, Italy, France and Spain. The governments of the US, India and Russia, as well as a number of colleagues and other significant organisations, are further contributors. Scientists at CERN turned on the LHC in July after more than 3 years of maintenance and upgrade work, and on July the 5th they discovered the first ever pair of tetraquarks, one of which is a new type. They also discovered a new sort of pentaquark, a new type of tetraquark. But how do quarks, tetraquarks and pentaquarks work? Quarks are the basic constitutions of matter. To put it simply, protons and neutrons, which make up the centre of each atom in the universe, are where they are most frequently found. 2 types of quarks are primarily present in protons and neutrons. The word for them are up and down quarks. Charm and top quarks are the names given to the heavier down quark copies, whereas strange and the bottom quarks are given to the heavier up quark copies. To create hadrons like the protons and neutrons that make up atomic nuclei, quarks typically combine in groupings of 2 and 3. However, they can also combine to form the 4 quark and 5 quark tetraquark and pentaquark particles respectively. The odd quark, a charm antiquark with an up and down quark and a pentagon that contains a charm quark, are among the new findings from the LHC. It's the first to have a peculiar quark in it. The charm quark, charm antiquark, up, down and weird quarks are the constituents of the new pentaquark. This is crucial because CERN researchers claim that the observation has statistical significance of 15 standard deviations, which is higher than 5 standard deviations required to claim the observation in particle physics. The LHC is now fully operational once more. According to CERN, the update appears to have been successful because 2 new tetraquarks and the previously reported pentaquark kind were detected. In the end, it appears that CERN is in complete control. The Earth is still standing despite the fact that their experiments replicate conditions that frequently occur in nature. The sole distinction is the meticulous monitoring and control of the laboratory environment. In either case, the actions of CERN may have a significant impact and control on those of us on Earth. However, the rest of the universe is likely to continue on its current track, expanding without stopping and paying little attention to what happens on our planet. What do you think of this then? Will this truly mark a new step into the future?